Hi, hello guys, welcome back to my YouTube channel. Myself Akshay. I'm studying in Sri Venkateswara College of Engineering in the branch of CSE. So today's topic is stochastic process. Let's move on to the slides. So let's discuss about introduction to stochastic process. Stochastic process or process that proceed random in time rather than consider fixed random variables x and y etc. or even sequence of IID random variables. We consider sequence x0, x1, x2, where xt represent some random quality time. Time is nothing but t. So in general, the value of xt might depend on the quantity of xt minus 1 at time t minus 1, or even the value x is lesser than. For stochastic process, we can take example as simple random walk. The moments of stochastic process. We can describe a stochastic process by its moment, that is e of xt, e of x square t, e of xt into xs, or either etc. When often use the first two moments. So for oftenly we use only two. So which are those means e of xt, e of x square t. So these are randomly used while solving the problem. So e of xt into xs is rarely used. The mean function of process is ext is equal to mu t. The variance of function of process is variance of xt is pi square t. The covariance function between xt xs is covariance of xt xs is equal to e into xt minus mu t and xs minus mu s. The covariance function between xt and xs is p of xt xs is equal to covariance of xt xs divided by root of pi square t root of pi square s. The moments are often function of a time. So okay, let's discuss about stochastic process. So we'll all know that stochastic process is a mathematical concept that describes the evolution of system or a random phenomenon over the time. It involves sequence of random variables which either variable represent the state or outcome of the system at a specific point of time. The term stochastic refers to randomness. So stochastic is known as randomness. Okay. Stationary stochastic process. Stationary stochastic process. It is a random process and it is also a realization. A stochastic process is said to be stationary if its mean and variance are consistent over time, and this value of covariance between two time periods. It depends only on the distance or a leg between the two time periods and not on the actual time at which the covariance is computed. A time series is not stationary in the sense just define its conditions or violated. It is called a non-stationary time series. So a time series is not a stationary in the sense just defined its condition or violated. It is known as non-stationary time series. Hence, a stochastic process is a family of random variables. This describes the evolution throughout time of some physical process. As usual, the random variable x of t are dependent on n's, and analysis the stochastic process is very difficult. Discrete time Markov chains DTMC. The meaning of DTMC is discrete time Markov chains. It is a specific types of stochastic process that has a very simple dependence among x. of t, and it render nice result in the analysis of x of t, t belongs to t, small t belongs to t, under very mind assumptions. Okay. Stochastic process, discrete time and continuous time. So there are two types. One is discrete time and another one is continuous time. A stochastic process is nothing but an ordered, not necessarily countable collection of random variables indexed by the index set t, shortly written as xt into t belongs to small t belongs to capital T. As usual, t bears a physical meaning of time. If t is continuous discrete set, well called index, or v is a continuous discrete time process. In many continuous times cases, we choose t is equal to 0. So we choose t is equal to 0 or infinity. And in the case, we write the stochastic process as xt into t is greater than or equal to 0. Covariance stationary process. So do you know that what is covariance stationary process? Okay, I'll explain it. A stochastic process is a covariance stationary if E of xt is constant. E of xt is constant when the covariance stationary is. Variance of xt is constant, and for any t h is greater than or equal to 1, covariance of xt and xt plus h depends only on h and not on t. This weak from the stationary requires only that means mean and variance are constant across the time, and the covariance just depends on the distance across the time. So